Hello, everyone. Good morning. Dear authors and invited guests, welcome to the technical session 6F. My name is Siddhi Avdi and I'll be your session moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology on Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being held in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held via Zoom meeting today and tomorrow on 5th and 6th April. I hope you all will enjoy this interactive session throughout the day. Now, in this session, in total, we will be having 10 presentations, and each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for the question answers. And after 8 minutes, I will be raising a gentle reminder since we have a time constraint. Also, there is another request to all the participants to please stay connected till the closing remarks. And if you face any issue or query or any technical problem, you may contact us. We will be solving those issues. Now, just before we get started, I would like to introduce you all to today's session chair, Dr. Nitin Sakre. Dr. Nitin Sakre is an assistant professor in the Department of Computer Engineering of Vishwakarma Institute of Information Technology, Pune. He has published more than 30 research articles, reputed journals with SCI, Web of Science, Scopus indexing. He has also published more than 100 books. His research interest includes data science, machine learning, computer networking, and Internet of Things. Good morning, sir.
Yeah, good morning, Siddhi. Good morning, everyone.
It's nice to see you here. Now we'll proceed with the presentations.
Sure.
So the very first presenter is G11 Visu Varanthanam from SRM Institute of Science and Technology, India. And the paper title is Automatic Accident Alert System. Sir, if you are present in the meeting, please start with your presentation. I think this participant is not joined yet. We can proceed to the next one and then later on we can have this presentation. So the next presenter is Sachin Singh. Sir, you are there in the meeting.
Yep, I'm here.
Would you be able to present?
Yeah, let me share my screen. Just give me
Yes.
like 10 seconds. So once again, good afternoon, everyone. And today, my first topic that I'm going to present is regarding the exploring 5G adoption trend. Basically, it's a comprehensive analysis of radio network technologies where we are moving, towards the 5G technology. And this adoption, what we are trying to do is that from the legacy network, we have started from 2G, 3G, 4G, and then moved to 5G. And even in 5G, what we are trying to do is that we are moving towards the O-RAN space. In O-RAN space, what we are trying to do is that initially, when there was a limitation, like when we are going with a specific vendor, we have to stick with that vendor for all the network elements. For example, let's say if we have a air interface where we are talking about the radio network technology, the towers technology, all the equipments needs to be from the same vendor. Whereas if we go towards the BSC and the BTS and the MSC things, all the network elements have to be from the same vendor. So that's why we were kind of, locked with the same vendor. Whereas now, in this new adoption of 5G technology, what we are trying to do is that we don't have to stick with the same vendor because, in this open radio access network, what we can do is we can basically have RAN technology from a separate vendor, CU from a separate vendor, DU, which is a distribution unit from a separate vendor. So there is no dependency on each other. So this way, in the modern world, in this 5G network, basically, we are kind of giving this open hand to the operator that they don't have to stick with one vendor only. Now, in this abstract, what I'm trying to show is the very high level statistics where I'm trying to show that, in what, which part of world has adopted this 5G technology, although this space is rapidly changing every day. So for example, in Germany, it is like 44.44 representation of LTE, 16.67 percentage on NR, which is the new radio, and the remaining 37% on the legacy technology. When we say legacy technology, that means it is related to 2G, 3G, and 4G. Though some people might say that 4G is still a new technology, in some part of world, yes, it is considered to be a new technology. But if we talk about developed countries like US, UK, and some even even in the Asian countries, 5G is now most probably a common technology that we are using nowadays. Global impact. I'm sorry. Okay. If there is no question, then I'll move to the next part. If we talk about the global impact, I think 5G connection has projected to reach around 3.6 billion by 2025, which is this year. And actually, if I tell you honestly, this we were thinking that we will reach to 3.6 billion by end of this year, whereas the kind of growth that we have seen in the world space of 5G, we are pretty sure that this figure may reach to around 4.5 billion. But as of now, I mean, we are still hopeful because there are still some part of the world which are still adopting this technology. And I can clearly see the limitation that why it is not being adopted by some of the world is could be because of the higher cost, because the initial deployment cost for 5G is extremely high, especially if it's a new network. When we say new network, that means if it's a greenfield network, it becomes almost, you know, extremely high cost for any operator to deploy. Whereas if let's say if there is any existing network, which has a legacy network like 2G, 3G, and 4G, then it becomes easy for them because they can simply, you can say that co-site. You can deploy in a co-site manner where there is already a 4G site in a particular tower, and on top of it, they can deploy the 5G network. So, this is, I mean, there are tons of challenges, but we can discuss those detail in case if someone has any interest, they can ask me about those questions. Um, but if I move towards some methodology, uh, yeah, in this, what we have discussed is about the data collection and processing, data transformation, data analysis, visualization, and validation. Of course, all these parts has been covered in our KPI part because, when we talk about the data analysis, visualization, and validation, every network has its own KPIs. When we say KPI, that means key performance indicators. In our 5G network, the main KPIs are retainability and accessibility. We like, all of us, use mobile, and in the network, the main KPI is when we talk about retainability, that means we are talking about the call drop. When we talk about accessibility, that means we are talking about the coverage. Having a good signal on mobile phone doesn't mean that your call can be successfully connected because it depends what is the RS, what is the receive level, and what is the trans level. Based on those KPIs, you can have a good connected call. So these are the a very high level KPIs that we validate, and then we have a dashboard. Dashboard is mainly for just a visualization purpose, but then we have a monitoring because dashboard, visualization can be done in tons of ways, especially in modern world. But main part comes to the monitoring where we have a national operating center, which we call as NOC, and that we have a separate team for that, which monitors the network and which monitors all the KPIs. Here, what we are trying to show is just a very high level flow chart, like how the data collection goes up to the adoption of 5G technology in various regions. And considering the time limit
Hello.
that is allowed. Yes.
Sir, sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Absolutely. I mean, that's what I was about to go there.
Yes.
And, if I just talk about the conclusion, I can say that, the significant highlight disparities in 5G is across Europe and Germany. I mean, of course, I think the reason of disparities I have already mentioned in the beginning because of high cost and all, but I still believe that, the kind of, yeah, you can say that approach that is there in 5G space, I think we can still strongly believe that there is a bright future in this 5G space, and I'm sure that the world will very soon adapt to this technology and progress towards it. So thank you very much for this. Any questions? I'm ready to take that.
Thank you, sir, for your presentation. Sir, are there any questions?
So, what are the exact challenges that are there when we talk about devices from different vendors?
That's a very good question, Nitin. I think one of the main challenge that we can see is that because it's when we say that device, let's say it's a new iPhone 16 is coming. So iPhone 16 doesn't mean that Apple is launching iPhone 16 and all the network will accept, adopt to those iPhone 16 and they can launch iPhone 16. No, because every network has been allocated a different frequency band. So let's say, in let's say in US we have N71 band, and whereas in UK it is N66. So that doesn't mean that that particular iPhone 16 can work on both the band at the same time. Yes, it can, but there has to be a FOA. FOA means has to be a trial, where each network first, before even the launch of any new phone, let's say iPhone 16, I'm just taking an example of iPhone 16, they first test that cell phone on their own network. When they pass, when Apple believes that yes, they have their certain standards, when that handset is passed on those standards, then only Apple allows that, hey, yes, you can launch my phone in your network. It is not the operator who can dictate that, okay, this phone will be launched on my network. No, it's actually the other way, that especially with the big phone manufacturers like Apple, Samsung, and some other manufacturers, they have their own set of standards. Once they clear that, then only they can launch. And there are certain different standards, like what kind of quality they want. Every handset manufacturer have their own standards, and based on that they let their devices launch on those particular networks. Thank you. I hope I answered your question. Any other question?
No, no, nothing from my side.
Thank you.
Okay.
That's all from my
Uh,
side.
Thank you, sir. Now I'll proceed to the next presenter. So the next paper title is Faculty Performance Modeling and Evaluation System using Classification and Sentiment Analysis Algorithms. And this paper will be presented by Romel J. Constantino from the University of Philippines. Sir, if you're there in the meeting, please start with your presentation.
Thank you very much. Allow me to present my
Yes,
presentation.
let me just stop sharing my screen.
Can you see my presentation?
Yes,
Thank you very much. So to start with, I am Dr. J. Constantino, a faculty of a certain institution here in the Philippines. So my presentation is all about faculty performance modeling and evaluation system using classification and sentiment analysis algorithm. Teaching is the foundation of education, while program education, accreditation, and institutional performance are directly correlated with its effectiveness. This study uses data mining algorithms to extract insightful information about the elements that go into good instruction, including both structured and unstructured data. One step in the KDD process, also known as knowledge database discovery, is the data mining, which deals with finding patterns in a big data sets. First is the extraction of data models to provide prediction and profiling that can be used for decision-making process. The knowledge discovery in databases provides a step-by-step mechanism in order for us to generate useful patterns that can be used in different domains. The first or the main modeling, evaluation, and deployment. Here in this slide, you can see the conceptual framework for the input. We have here the personal attribute, faculty evaluation, and faculty credentials. While the process includes a prototype model, first is the classification algorithm that defines the different data of the faculty, then the decision tree, while that comes in the sentiment analysis, then the naive-Bayes algorithm, the mapping analysis that has the faculty performance modeling and evaluation system using classification algorithm and sentiment analysis algorithm. For the conceptual framework, it includes the faculty performance, professional attributes, partnership and linkages, and student evaluation. For the SOP, we identify such as the salient features of proposed faculty performance modeling, the data model can be used, how effective the data in terms of faculty performance classification, how sentiment analysis can be used to extract useful patterns, and how accepted the system using SQM such as 25010 is perceived by the experts. And the methodology part includes this KDD, the data selection, data pre-processing and transformation, data mining, interpretation and evaluation, and the knowledge utilization. For the results and discussion, the data model of the J-ported algorithm, which is the key formula to split an entropy and information gain. This is the result. The J-ported algorithm. A confusion matrix was utilized to assess the model's performance, a helpful tool for assessing how well your classifier can identify tuples and multiple classes in confusion matrix. For this part, we see the table accuracy and error measures identified by the respondents. Like the model can still be used by adding additional attributes. The researcher developed an application entitled Faculty Performance Modeling and Evaluation System using classification and sentiment analysis and algorithm. The J4 algorithm is a powerful technique under the decision tree algorithm, while in terms of sentiment analysis, the researcher utilized various tools and frameworks to implement sentiment analysis. That would be all. Thank you very much for the paper ID 729.
Thank you, sir, for your presentation. Are there any questions from session chair?
No, Siddhi, no questions from my side.
Thank
Thank
you
you,
very
sir. Now
much.
I'll proceed to the next presenter.
Thank you.
So up next, we have optimizing autoencoder architectures for network anomaly detection using mimetic algorithm. And this paper title will be presented by Omar Ahlamadi by University of Sharjah, United Arabs.
Hi, good afternoon.
Sir, yes, good afternoon, sir. Would you be able to present now?
Okay. Are you able to see my screen?
Yes.
Okay, thank you. Okay. So good afternoon, everyone. My name is Omar Hamadi, and today I'll be presenting our research on optimizing autoencoder architecture for network anomaly detection using mimetic algorithm. Now, this is our agenda for today. We organized it in a way to tell the story of what was the motivation behind this, how a mimetic algorithm was used, along with the two algorithms used for its creation. Then we showcase the experimentation and results and discuss them. And we'll also have a look into our future direction. So, as you know, modern network infrastructure have become increasingly complex, leading to significant cybersecurity challenges. Traditional intrusion detection systems primarily rely on predefined signature and rules, making them not practical for detecting new or what they call it as zero-day attacks. In this context, machine learning, deep learning, and specifically for this study, autoencoders offers a promising solution for anomaly detection by learning the normal behavior of network traffic to then identify anomalies. However, one of the major challenges here is optimizing the autoencoder itself for the specific task at hand. In this study, we used a mimetic algorithm to do that, which combines genetic algorithm for global search with simulated annealing for local refinement. And so our main contribution here is automated autoencoder optimization, where we develop mimetic algorithm that combines genetic algorithm for exploration and simulated annealing for refinement. We applied our optimized autoencoder to network anomaly detection using Zclog datasets, and we demonstrated that the optimized model achieves 0 false negatives and minimal false positive, which proves that it is practical for intrusion detection application. And we'll look into that. So first, let's look at the literature review. This is just a summary, many previous studies either adopt fixed architecture for autoencoder or focus solely on optimizing specific parameters. As you can see from the table, our approach differs as it's the only one that utilizes mimetic algorithm. Okay, and it's considered all the 5 key elements that makes up the autoencoder, which includes the number of layers, neurons per layer, activation function, and the optimizer selection. So we talked a lot and said mimetic algorithm. What is a mimetic algorithm? Mimetic algorithm is an optimization technique that combines evolutionary algorithms like the genetic algorithm with local search method to find high quality solution efficiently. So to put it simply, it takes the explore power of genetic algorithm and combines it with fine-tuning ability of local search. In our approach, genetic algorithm is used in the global search part to explore potential architecture. Simulated annealing, which is the local search step here, refines and fine-tunes the selected best candidate. The dataset is the Zclog dataset. Specifically, we use 5 datasets, each with varying sizes, but shares the 21 standard network connection features that you can get easily from Zclog, like protocol, ports, bytes, size, network flags, etc. So let's talk about the process of the mimetic algorithm now and on what we have done. So the first part is the global search genetic algorithm, which follows 6 steps that repeats until we reach the final generation. First, 2 individuals are selected. Then we evaluate the fitness score using the reconstruction error. A crossover could happen, and I have included an example in this slide. As you can see, the chromosomes are the number of hidden layers, the hidden layer contents, and the optimizers. Based on the fitness score, the one with the lower reconstruction error is the winner. And so for crossover, the loser inherits some of the winner chromosomes. During mutation stage, random mutation is applied to the loser, and then the new modified loser replaces the original version in the population. We calculate the reconstruction error of this new child and track the best architecture. Once we end, we should have a promising model from the genetic algorithm. So let's look what happened here. So using the population size of 20, we ran this for 100 generation and recorded the architecture to be used by the next step. As you can see, the graph, the reconstruction error decreased from 0.5 all the way to 0.23 at the end of the genetic algorithm step. The key here is the reconstruction error always. After the global search part, it's time for the local search. After identifying the best architecture through the genetic algorithm, simulated annealing fine-tunes it, and the focus here is the bottleneck layer. The mid layer, the process starts with high temperature to allow exploration, gradually cooling down to emphasize exploitation. The fitness evaluation here is again the reconstruction error. Let's look at the results. It was ran for 100 iterations, starting with the reconstruction error of 0.2 and reaching reconstruction error of 0.12 at iteration 21, where it plateaued. Now it's time to evaluate the performance of this autoencoder. Okay, we got the best autoencoder using using the mimetic algorithm. So we took it and trained it for 50 epochs on normal network traffic. To evaluate the result, the performance metric used was the confusion metrics, true positive, true negative, false positive, false negative, and of course the accuracy, since it's a binary classification problem. As for determining potential anomalies, using this system, we employed a threshold-based approach where reconstruction errors were compared against predefined percentile threshold, the 90th, 95th, 97th, and 99th percentiles, which were calculated during the training phase. If the reconstruction error of a network connection exceed chosen threshold, it was classified as anomaly. And so we evaluated the optimized autoencoder on the 5 Zeek datasets. We recorded the result of the 4 different percentile-based threshold determination method. The 99th percentile threshold yielded best results, achieving 0 false negative and minimizing false positive across all the datasets, as you can see in these tables. So achieving the best accuracy at the 99th percentile threshold highlights the exceptional robustness and precision of our optimized autoencoder. Let's think about it. Typically, the 99th percentile represents the strictest criteria
Hello.
for anomaly detection. Yeah.
So sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yeah, sure. So as I was saying, the work demonstrated that our optimized process resulted in a well-generalized and highly efficient autoencoder architecture, which makes it practical and reliable for real-world intrusion detection. For future work, we are looking ahead. We plan to explore more thresholding techniques beyond the percentile method, hoping to find better solution, and finally integrate our optimized model into federated learning framework. Thank you.
Thank you so much, sir. Are there any questions?
I have just one question. Question is, like, attacks have been considered. For example, as I see in table, there are like two types of attacks mentioned: reconnaissance, and there was one more. So, how many such type of attacks are have been considered in data set? Yeah, yeah. This table.
Well, based on the collected data set, the UFW Zeek data set, currently in the 2022 version, it has only these 2 attack types, the reconnaissance and
Okay.
discovery. But in the 2024, they are adding more attacks. So hopefully we'll be using them in the future work.
Order. Okay. Thank you, Omar.
Thank you, sir.
Thank you.
Now I'll proceed to the next presenter. So the next paper title is Optimizing DevOps with Ansible, a machine learning driven approach to predictive infrastructure management. And this paper title will be presented by Vishal Srivastava from Arya College of Engineering and Information Technology, India. I request Vishal sir to please start with your presentation.
Let me share my screen.
Yes.
Good afternoon, everyone. My topic is optimizing DevOps with Ansible, a machine learning driven approach to predictive infrastructure management. And my paper ID is 734. The integration of DevOps with intelligent automation tools has become essential in managing modern dynamic infrastructure. By enabling machine learning model into Ansible playbooks, the system may address potential issues, reduce operational cost, and enhance system reliability and scalability. Key areas which we are discussed in this paper are challenges in traditional infrastructure optimization. Traditional systems often respond after the issue occurred, like CPU overload, memory leaks, and disk failure. Lack of predictive insight leads to unplanned downtime and performance bottleneck. The need for AI-powered automation. These challenges make a strong case for integrating machine learning and Ansible to create predictive and a self-healing infrastructure system that dynamically allocate resource, minimize cost, and operate autonomously with a minimal human intervention. The introduction part is DevOps and automation evolution. DevOps integrates software development and IT operation to enhance software delivery speed, reliability, and scalability. Traditional DevOps automation tools like Ansible have the streamlined configuration management, development and system monitoring. The role of Ansible in DevOps. Ansible and open source automation tools, which are widely used for configuration management, application deployment, and task automation. However, Ansible lacks predictive capability, which limits its ability to prevent infrastructure failure. Integration of Ansible with machine learning. This research explored the integration of machine learning model with Ansible playbook to create a self-optimizing predictive infrastructure. This proposed system collect a infrastructure data, train machine learning model, and trigger Ansible automation. Now, the machine learning model for predictive infrastructure management. To overcome this challenge, machine learning driven predictive model are introduced into DevOps workflow. Machine learning algorithm can analyze historical system performance data, predict resource utilization trends, and detect anomalies and performance bottleneck. Now, the proposed methodology, Ansible with machine learning based predictive model to optimize DevOps infrastructure. It follows a structured approach in encompassing data collection, machine learning model training, automation with Ansible and performance evaluation. Now, first with data collection and pre-processing. From data for the data are the like cloud infrastructure logs, system performance metrics, and application telemetry data. Key parameters include CPU usage, memory allocation, network bandwidth, and also this input output. Now the pre-processing step, data cleaning. Now in data cleaning, we remove the redundant or inconsistent data, and after that we do the feature engineering part where we extract the relevant features like peak usage trends and anomaly detection. The next is machine learning model implementation. The machine learning based system employ multiple model to enhance predictive infrastructure optimization, like the time series forecasting, regression analysis, clustering, and anomaly detection. Now, here the comparative analysis between the traditional infrastructure management and the machine learning driven predictive management with Ansible. Now, the approach in the traditional management are the issues addressed after it occurred. But in case of machine learning predictive management with Ansible, it predict and prevent issue before they before they happen. Now the question is how we can predict and prevent issue before they happen. First, we collect the real time metrics, use monitoring tools like Prometheus or AWS Cloud Watch to gather data like the CPU and memory utilization, which I was already tell. This inputs output, network latency, throughput, application resource time, system logs, and error rate. These metrics are stored in real-time series database or log collection. Now after we apply the machine learning model to forecast feature issue, feed the collected data into the predictive machine learning model. For example, like the time series model for forecasting resource usage, and the regression model for the predictive when memory or CPU will exceed threshold, and the clustering we use for the detect a abnormal work pattern. Now here the resource utilization, like the often insufficient due to the over provisioning or underutilization. But in case of the nutrient are the optimizing through forecasting and intelligent allocation. So these are the comparative analysis between the. Now we are the conclusion and future work. The conclusion is the machine learning driven infrastructure optimization. The integration of machine learning model with Ansible enhance predictive infrastructure and management, shifting from reactive to a proactive approach. Eliminating now we are the predictive automation with Ansible, like time series forecasting, regression, anomaly detection, enable a real-time system adjustment, ensuring efficient infrastructure and performance. Now the improved system reliance, automated predictive maintenance, minimize the failure and downtime enhancing reliability and system uptime. Now the future work in this scope are the enhanced machine learning model accuracy. Like the future research can be focused on improving predictive accuracy by using more advanced machine learning technique, like the deep learning model or reinforcement learning, multi-cloud or hybrid environment, expanding the methodology to support the multi-cloud and the hybrid infrastructure will improve and improve the security and compliance automation. Integrating AI-driven security framework can enhance threat detection, compliance monitoring, and risk mitigation. Now, the broader DevOps tools integration. Future work can be extended the integration to other DevOps tools like such as Kubernetes, Terraform, Jenkins to create more comprehensive predictive automation and framework. So that's all. So that's all from my side. Thank you all of you.
Thank you, sir, for your presentation. Are there any questions?
No, Siddhi, no questions. You can proceed.
Okay, I'll go on to the next presenter.
Thank you.
So the next paper title is Real-Time Aquatic Wildlife Detection for Underwater Fish Identification, which will be presented by Dane Brown from Rhodes University, South Africa. Sir, if you're there in the meeting or any of other co-authors, you may start with your presentation. I think he's not there in the meeting. We'll proceed to the next presenter. The next paper title is Resilient DC Microgrid Energy Management System, SOC-based control with fuel cell backup. And this paper will be presented by Tanmay Hassan from American International University, Bangladesh. Sir, please start with your presentation.
Can you see my screen?
Yes, we can see your screen.
Hello everyone, I am Tanmay Hassan. Welcome to the 9th International Conference on Information and Communication Technologies for Intelligent Systems. My paper title is Resilient DC Microgrid Energy Management System, SOC-based control with fuel cell backup. My paper ID is 658. Here is the content I'm going to cover in this presentation. Introduction, research background, literature review, problem statement, goal of the work, block diagram, flowchart, result analysis, conclusion. A group of interconnected loads and distributed energy sources that operate as a single controllable entity in reference to the grid. A microgrid may connect to the grid and disconnect from the grid, allowing it to function in both grid-connected and islanded mode. Microgrid face challenges in controlling and sustaining stability due to the large share of renewable energy sources. In research background, there is much research on feasibility on renewable energy source-based system like islanded mode, grid-tied mode in various areas across the country. The main reason is the ability to generate the clean, cost-effective, and ecologically friendly electricity. The research provide a new flexible energy management system to reduce the hybrid microgrid running. The AC or DC microgrid may connect the distributed energy sources, energy storage system, and load. Optimizing distributed energy source used require a safe, reliable, and intelligent energy management system. This paper explains a DC microgrid construction, control, and energy management system. Here is a literature review I have made in a table. Uh, if you see the reference number 5, 6, 7, 8, 10, 11, and 13, all of them use the PV and battery. But some of them, like reference number 7 and reference number 8, they don't use the supercapacitor. And none of the reference doesn't use the fuel cell as their backup. And none of them have the SOC-based charging control system. Our problem statement was that without energy management system, there are huge energy losses. Overcharge and discharge impact the lifespan of the battery and the supercapacitor. Our goal of the research is to design a standalone energy management system for hybrid microgrid like PV, battery, supercapacitor, fuel cell to reduce the energy loss. To develop the SOC-based charge and discharge control system for energy storage system like battery and supercapacitor to enhance the lifespan of the energy storage system. Here is a block diagram of our system constructed with solar PV, battery, supercapacitor. These two are this two is our energy storage system, and here is our backup cell, which is fuel cell. All of them are DC, AC to DC converter, DC to AC converter, and all of them are connected to the load through a EMS. Here is the flowchart of the case 1. Firstly, it will measure the energy source parameters of solar power. If the PV power equal to the demand load and the statement is true, then the battery and supercapacitor stop charging and discharging, and fuel cell will remain turned off. If the statement is false, then it will continuously measure the PV output voltage and current and power. Another case is if the PV power less than demand load, then it will continuously measure the PV output voltage, current, and power. If the statement is true, then it will measure the battery SOC, voltage, and current. If the battery SOC in a range greater than equal 20% and less than equal 80%, and the statement is true, then it will start discharging. And if the statement is false, then it will check the another statement. The another statement is if the battery SOC is less than 20% or greater than 80%. If this statement is true, it will stop discharging, or otherwise it will start charging. After that, it will measure the supercapacitor voltage, current, and power. If the supercapacitor SOC is greater than 20% and less than equal 80%, as usual, if this statement is true, it will start discharging. Otherwise, it will take the another statement, the SOC is less than equal 20% or greater than equal 80%. If this statement is true, then it will stop discharging, and otherwise it will start charging. And this is our case 3. If PV power is greater than our demand load, then it will measure the battery SOC. After that, it will measure the supercapacitor SOC. All of them will be in action when it is in range. Otherwise, it will stop charging and discharging. And here is our case number 4, when PV power is absent. That means PV power is 0. Here is our result analysis, and we can see all in our DC bus voltage of the proposed microgrid. Our DC bus voltage is remain constant around 600 voltage. And previously we talked about the SOC. Here is in figure number 7, we can see the SOC is maintaining 20 to 80%. It's not getting greater than 80%. Same goes to this one also. And figure number 8 is supercapacitor SOC, and
Hello. Sir, sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Okay. There is a comparison table, and we can see some of them have the limitations, and our proposed system has mitigate all the problems like PV, battery, supercapacitor, fuel cell backup, energy management system, and SOC-based charge control and discharge. In this project, we try to resolve all these limitations, and in future, the research on the power management stability can improve the energy management system and integrate the additional renewable energy source like wind and etc. Thank you.
Yeah, thank you, Tanmay. I have only one question. Like, is the prototype of this project is ready? And how many entities you have considered for performance comparison?
So initially, I have simulated the system, and we are working on this to build an EMS physically, and so that we can practically implement on the field. After that, we can compare the simulated result and the practical result. And we have considered the solar PV, battery, supercapacitor, and fuel cell. And this is our DC microgrid, sir. We haven't connected to the grid. Currently, it is under. Hello, can you hear me, sir?
Yes, we can hear you. We can hear you.
Hello.
Yes, we can hear you, Tanmay. Please go ahead.
Uh,
Yeah. All right. Siddhi, over to you.
Okay, let's proceed to the next presentation. Just give me a second. Uh, the paper titled Real-Time Aquatic Wildlife Detection for Underwater Fish Identification, presented by Dane Brown from Rhodes University, South Africa. Sir, are you there in the meeting?
Yes, I am.
Please start with your presentation.
Okay. Can I share my screen?
Yes,
It says someone else is sharing. Okay,
I've
yeah, I
stopped
can share
sharing
now.
my screen now. Yes.
Okay, thank you. Okay, thank you. So thank you for introducing me. So let's start on the importance of why we're doing this. So there are various different ecosystems, freshwater, brackish water, and marine water. And all of them face the same global challenges: pollution, habitat degradation, invasive species. Now, the vast majority of the oceans are also still unexplored, so only about 5% of the oceans are explored. And you can imagine that this is quite a big task to undertake in a manual fashion. And there are a bunch of different ways to do the exploration. We focused on something called baited remote underwater vehicles, or videos, where we place a video stationary inside the ocean, and also remote operated vehicles where either someone is controlling the camera themselves at hand, or a robot does it. So we'll focus on marine because that's the sort of data that we're focusing on at the moment. And there's all kinds of problems over here. You can imagine fishing boats overfishing. There are invasive species that are causing competition for native species, and all kinds of other reasons why we're trying to monitor the ocean. Now, one of the other reasons are as well that the human population, 40% of it lives close to the ocean. And of course, you can imagine the consequences of that sort of stuff. Now, computer vision is, of course, one of the solutions we looked at for helping to monitor the ocean better using cameras. And I talked about baited remote underwater vehicles earlier and remote operated vehicles. And that's going to be used to do detection and classification of different species of fish. So so we start off with the camera in exploration mode, and we have two public data sets that we used as benchmarks, and our own data set that we also collected in collaboration with a marine ecologist. And this is also more controlled data that you could also get, but we didn't do this. This is called aquaculture, where you can do things like counting, behavioral monitoring very easily. Now, this can be done with browse and ROVs too in future, but for now, we're focusing on fish detection and classification by using some image pre-processing and, of course, classifying the fish. I'm not going to really go through this because I think most people know CNN's work, but what's important to note is that as you train more layers, you get more specific features, and the more convolutional layers will end up focusing on the lower fin of the fish. That is the focus. The curse of dimensionality still exists, and we try to reduce dimensionality as much as possible. And of course, we don't want to overfit, so we try to regularize the output. And to do the actual classification or detection, we need to have a fully connected layer, and that's basically what this is over here. Now, based on the CNN, a bunch of different object detectors popped up. Started off with the RCNN, which works with regions, and it's a two-stage detector. And then SSD tried to make a faster one that's one stage, but it was unfortunately very inaccurate. And then YOLO came along to try to fix both and reduce the trade-off between accuracy and speed. However, it still struggles a bit with small objects, but it's better than RCNN at detecting small objects. There's still a bunch of challenges that we're trying to face, or that we're facing over here. That's bad lighting, murky waters, and complex backgrounds. But as we keep exploring different methods, it has been improving. What are we going to focus on in this research is a comparison between these three models over here, RetinaNet, Faster RCNN, and YOLO V8. And can they all perform at real time without requiring specialized hardware? So we're going to compare it with laptop and desktop. And we're doing this because instead of having a biologist or a marine biologist or ecologist manually working through different images, we can rather have a structured system that does it for us. On to the data that I was talking about earlier. The first benchmark data set is called Deep Fish, and it has 20 different habitats, but it only has one kind of fish. Fish for Knowledge, on the other hand, another benchmark data set, but it has 8 different classes. Now, one of the big problems with computer vision of object detection stuff is that you have to label images, or labeling takes much longer than labeling for classification alone. So we only ended up labeling 1,880 about. But you can see that there are a lot of different fish inside each image of these 1,880. This is our own data set. We collected data in Seychelles at Aldabra, and there were 363 classes originally, but we quickly found that there are too few images available per fish, so we chose the top 5 classes instead. So this is the summary. As you can see, the top 5 classes, and this Aldabra dataset is very similar to Fish for Knowledge in terms of size. whereas Deepfish is a lot bigger, but it's only one class. Standard 70-20-10 split for training, validation, and test sets were used, and a standard laptop and desktop was used with the same GPU, but you can imagine that the laptop's one is normally a bit slower. The image
Hello,
sizes were varied between 640,
hello,
480, and 3. Yes?
sir. We are past the presentation time. Can you please get to the conclusion?
Okay. So just Retinate didn't work very well. RCNNs worked well, and YOLO. And we found that YOLO was by far the fastest, 4 to 5 times faster than all the others. And you can see it's the same for all of them. So I can conclude now by saying that it's hard and slow to annotate. Too crowded, stuff like this is very difficult to detect. But the speed, we showed that the speed is excellent now, and we'll focus on future challenges such as getting better accuracies, and we already have gotten better accuracies. Thank you. Any questions?
What was the problem happened with the number of epochs?
Well, the number of epochs, 200 epochs, but early stopping is used. So early stopping is used with the patient set to 50.
So are you satisfied with the results that you obtained with 50 epochs?
Yes, so most of the time it stops just before it starts overfitting. So we left the patients as is as 50, and we're happy with that.
All right. Okay. Siddhi, over to you.
Okay. So the next presenter is Nisha Shamsuddin from Mahatma Gandhi University, India, and the paper title is Study and Analysis of Automated Examination Systems in Indian Higher Educational Institutes, a comparative approach and a unique model for Mahatma Gandhi University. Nisha ma'am, you can start with your presentation.
Thank you. Is my screen visible?
Yes.
Thank you. My paper title is Study and Analysis of Automated Examination System in Higher Educational Institutions, a comparative approach and a unique model for Mahatma Gandhi University. Examination is an essential and intricate practice involving rigorous assessment and evaluation, which a university cannot stay away from. It's an attempt to walk through the existing conventional examination system of Mahatma Gandhi University, which is a state university of Kerala, to identify the possible improvement areas and propose a new solution. The problem we have identified is a manual evaluator assignment, time-consuming paper handling, delayed valuation and result processing, error-prone data entry, lack of transparency and efficiency. Certain challenges we have faced are diverse workflow across institutions, because our university is a state university and we have 260 plus affiliated institutions span across the South Kerala. Resistance to automation, ensuring data security and integrity, seamless integration with existing system, and real-time monitoring and transparency. The solution we are providing is a QR code scanning, faculty course mapping, updated faculty database, online script evaluation, digital script transport, fast revaluation, and automated storage and tracking. The project is divided into two phases. That is, the research have been completed within the two phases. First phase, we have to identify a comparative case study and analysis. That is, we have to identify leading institutions with successful automated examination system. For that, we have visited Delhi University, Anna University, and Mumbai University. This is the famous universities span in the India. The phase two is the system development and the implementation. We have to design, develop, and implement and maintain a unique model for Mahatma Gandhi University. The objectives we are providing is the QR code scanning. The highlight of our project is the QR code based scanning, faculty course mapping, online script evaluation, digital script transport, fast revaluation, and automated storage and tracking. Moving on to the methodology, we begin with the post-examination. Post-examination means once the examination has been happened at the examination centers. After that, answer script from the examination centers are transferred to the university. Then false numbering is performed on that each answer script. Then bundling the answer script and transferred it to the evaluation camps. After that, faculties or the evaluators will on paper evaluation will be done. Then the answer script is score and attendance sheet again transferred back to the university. Then again, score entry is happening at the university side. That is double entry performed by 2 departments of the university. Then stacking of answer script for further evaluation and the final result processing is happening. These are the certain stages that we have to be moved from the existing examination system, or we have to apply automation. That is highlighted in a different colors. The base or the financial expense that happen for our university is the bundling the answer script and transfer to the evaluation camps. And again, after evaluation, that same answer scripts have again bundling and transfer back into the university. So we have to remove all these stages from the existing automation system. So next, moving on to the proposed examination system. In the proposed examination system, we are dividing the examination system as 3 stages. First one is the pre-examination stage. Here, the hall ticket is generated. Once the hall ticket is generated for the corresponding students, a QR code is generated for each student. Then that transfer the QR code to examination centers. Then happen the examination. After getting the QR code based answer script, the evaluators will be paste that QR codes on the answer scripts. Then examination will be happen. And after the post-examination means once the examination has been completed, attendance entry has been done and transferring the QR code answer scripts again back to the university. Then we are scanning the answer scripts at the university side and stacking for the further evaluation. Then once the answer scripts have been scanned and available online, each faculty can be logged in on the portal and they can on-screen evaluation can be done and the score entry will be performed. So result processing will be more faster and error-free. This is the highlights of our proposed examination system, that is online attendance entry, transfer QR code to answer scripts, then scanning, stacking, and the on-screen evaluation. The next stage is the reevaluation system. Reevaluation system is another part of our project. That is, first case is the answer script has been on-screen evaluated, and the second stage is the reevaluation system. Here, once the request for the reevaluation is happened, then we can fetch the scanned copy of answer scripts. Then on-screen evaluation is performed by a blind assessment, then updated the student records. These are the certain experimental results of our project. That is, we have prepared a questionnaire comprising 20 questions and it is approved by the syndicate of the Mahatma Gandhi University, and 40 faculty members from various departments of Mahatma Gandhi University have been evaluated. And some of the sample scores have been shown on my experimental results part. From that screen, we can be easily identify that it will be time taken for the evaluation is more easier for the automated system. And these are the user experience shown based on the questionnaire evaluation. Then some areas to be discussed is the cyber security in automated examination system. When we perform an automated examination, we have to perform role-based access control with periodic reviews, data classified as sensitive, confidential, or public, encryption in transit, logging and monitoring for data access changes and disposal, ensures integrity and confidentiality of student records. Then the cost-benefit analysis. In the first stages, I have told you that there is a transfer of the answer script from the examination centers to the evaluation camp, and once evaluation has been completed, again transfer back to the university. These stages will be eliminated in the automated examination system, and reduces the faculty travel also. For faculty adoption and training, we have to perform certain structured training workshops, phase implementation on the pilot phasing, and emphasis on cybersecurity. These are my conclusion. It's improved efficiency and transparency and user satisfaction, reliable and accurate handling of large answer script volumes. 93% of the users preferred automated system for future use as per based on our questionnaire evaluation. This is a future scope. Integrate AI for plagiarism detection. We can automate the evaluation of subjective answers also. These are some of my references. Thank you. Is there any questions?
Ma'am, how this project will address the scalability issue?
Scalability issues, actually, our university is a affiliated institution with 260 plus institution. As a first stage, we have evaluated this process or the prototype model on reevaluation process. So currently, we have successfully completed the evaluation of 21,000 answer scripts currently. So we are just moved on to the first batch is the 21,000 answer scripts of the reevaluation stage. It has been completed successfully. Because we have using servers, and already the manual scripting processing is going on our university, and we have powerful servers. So this there is no scalability differences in that cases also. We can directly apply to that process.
Okay. Siddhi, over to you.
Thank you, ma'am. Thank you, sir. So the next presentation,
Thank you.
next presenter is Abdul Azami from Rajshahi University, Bangladesh. And the paper title is TIG unit, a thresholded input guided modified UG net for separating lung region in chest X-rays. Sir, I request you to please start with your presentation.
Yeah, please let me share my screen.
Yes.
Am I visible?
Yes.
Okay. Hello, everyone. This is Abdul Jami from Russia University of Engineering and Technology, Bangladesh. I am happy to be able to present my study on TIG unit plus plus, a thresholded input guided modified unit plus plus for separating lung region in chest X-rays. I was co-authored by these wonderful persons, Shadman Soban, Mohiuddin Ahmed, and Rakibul Islam. These are the outline of my today's presentation. Lung diseases like COPD, lung cancer, tuberculosis, pneumonia, and many more, they are the global health concern now. According to WHO, respiratory illness accounted for 3 of the top 10 causes of death in 2019, killing more than 8 million people per year. And you know that chest X-ray is widely used by the doctors and the radiologists to identify these lung diseases. And nowadays, AI-based chest X-ray classification is a hot topic in today's research field. And accurate lung segmentation can help for more robust classifications by allowing researchers to focus on the relevant part of the chest X-rays only. But this process is actually not very easy. Varying lung shapes, sizes, and overlapping organs makes this process difficult, even for the experienced radiologist to segment lung regions. We figured out that the thresholded image almost roughly outlines the lung region in a chest X-ray. You can see here in the figure that the black pixels of the thresholded image actually roughly outlining the boundaries of the lung. You can compare it with the mask provided at the right side. There is pretty good similarity between them. So we got an idea to utilize this thresholded image as well as the original chest X-ray for better segmentation result. Various methods has been proposed by various researchers that includes thresholding, region growing, active control models, or recently machine learning approaches. And CNNs are actually best among them. And UNET is a very famous architecture for segmentation, especially medical imaging. And UNET++ is a modification of that standard UNET. It has more nested, dense skip connections and additional convolutional layers to refine features more perfectly. These are the literatures that we reviewed before getting into this study. Almost all of them used CNN-based methods. Some of them used custom units. Some applied some attention mechanisms. Even some applied their custom encoder-decoder-based models. Even some used also GAN-based method, generative adversarial networks. All of them have some limitations, like GAN can sometimes generate synthetic images, but we can actually ignore their limitations because all of them achieved a very competitive and satisfactory scores. So our goal was to improve their segmentation scores a little bit more. These are the datasets that we utilized, the Shenzhen, Montgomery, and the JSRT dataset. These are the pre-processing steps. First, we applied Clahy with clip size 2, and then this image was resized to 224 by 224, and it was taken as the original input. Then this image was at also thresholding was applied to it, and we get the thresholded image from it. And I should tell you that our model actually have 2 inputs, and these are those 2 inputs. Here you can see our TIG unit plus architecture. That is what we proposed here. This architecture is pretty similar to the unit plus L4 architecture with some minor modifications. The major modification is at the inputs. You can see a threshold image here. It was passed lately to that network, not at the beginning or not at the end. Why so? I will explain this later. For generalized training, we had to apply real-time data augmentation techniques. So we applied random rotations up to 15 degrees and random scaling up to 0.8 to 1.2. These are the evaluation metrics we used to evaluate our model's performance: dice coefficient, Jacob index, accuracy, and the AUC. Here are the equations. You may check them. We use dice loss as the loss function. We applied 5-fold cross-validation technique with each fold having 100 epochs. Batch size was kept 16 and 80-20 test train split, train test split was done. Hyperparameter training is pretty crucial for training deep neural networks, especially for us. We set the initial learning rate to 0.0001 and minimum threshold was 10^7. We reduced the learning rate on plateau after 15 epochs by a factor of 0.2. Early stopping was set up with on validation dice with patience of 20 epochs, and the best models were saved on base validation dice scores. Here you can see the scores of our TIG unit plus model across different data sets, and you can clearly see that our model performed really well on almost all the data sets. And this proves the generalized behavior of our model on diverse data sets. Here is a comparison of our TIG unit plus with the traditional unit plus architecture. And you can see that our TIG unit plus achieved better performance than the unit plus architecture in all the data sets shown here. And this actually proves the effectiveness of the thresholded image passed lately to the unit plus architecture. This is the comparison of our model with other recent works, and you can see that our model outperformed other state-of-the-art works on Montgomery and the combined dataset. Combined dataset means the combination of Montgomery, Shenzhen, and the JSRT dataset. And it also achieved a competitive score on the JSRT dataset as well. Here you can see some predicted mass of our model, and you can compare them with the original mask, and you can clearly see that these two images are pretty close to each other. Well, now let's talk about why our approach worked better. First of all, due to the dual input strategy, the way we utilize the original chest X-ray and the thresholded image to improve the lung boundary detection, especially for the disease-affected cases. As you, I should tell you that Shenzhen and the Montgomery dataset contains several disease-affected cases like tuberculosis. And obviously the unit plus architecture and the use of the thresholded image. And the most important is that the late introduction of the threshold image. You know that thresholding an image will remove most of the important, most of the features of the image. So for better generalization, the original image was given most priority.
Hello. So sorry for the interruption, but we are past the presentation time. Can we please conclude it?
Yeah, I'm almost at the end.
Yes.
So we actually keep the less impact than the original image for the threshold image. So in conclusion, TIG unit plus advances the lung segmentation, and it outperforms several state-of-the-art models on Montgomery, JSRT, and Shenzhen datasets. We propose future works to extend this methodology to other medical imaging tasks like lesion segmentation, optimize efficiency for broader applications. Researchers may focus on making the model more lightweight, or they may add attention mechanisms as well. Here are the references. Thank you so much. That was all from me, and questions are appreciated. Thank you.
Can you go to results table?
Yeah. This one or this one?
Yes, yes. So what is the size of data sets that you have considered?
Okay, let me go to the slide. Here is the size of the datasets.
And the all images are in like good resolution, or you have to do
Yeah,
any
they are at very good resolution, and but I resized them to a lower resolution like 224 to 224 for that was actually enough for me actually to segment the lung region.
and how did you store these images?
It was in the PNG formats, and for my training, I stored them in a .npy format,
Okay.
numpy format.
And what do you mean by combined? So it is the combination of like from both the
All the
data
data
sets?
sets. Yeah, all the data
Okay.
sets.
Thank you. Siddhi, over to you.
Now we'll go on to the last presentation of today's session. So the very last presenter we have here today is Kong Duan Lee from Vietnam National University. And the paper title is VD rise detection and segmentation in UAV imagery using deep learning models. Sir, I request you to please start with your presentation.
Yeah, thank you. I'm here. Everyone, I am Phong Đoàn Lê. I am from An Giang University, Vietnam. Today, I would like to present my topic is web-derived detection and segmentation in UAV imagery using deep learning model. So my presentation contains two parts: introduction material, recent discussion, and future work. To begin with, I will introduce some the challenge in right cultivation. The first wet derived can be recognized as the unwanted plant that compares with the rye. So it might increase the cost in production and reduce the growth rate, reduce the quality of rye production. What difference between the rye and the wet? So you can see here, it's the web is a little bit stronger and it will a strong dominancy. The reason because in the red rye studied with the locality shift or multiple cropping system is one of the issue in Vietnam. As you know, at the moment, the smart agriculture for wet detection is more popular. By using UAV, it provides high resolution image for precision agriculture because it has a low cost, safe real-time monitoring. And another is that the machine learning for wet detection can be followed by step image capturing, reprocessing, feature extraction, and finally segmentation or detection. The deep learning can improve accuracy by integrating feature extraction for other stuff in computer visions. In this study, we employ deep learning for wet derived detection and segmentation. The deep learning model can enhance the web detection. It can be applied in several fields, for example, in bean, coffee, potato, wheat, and rye. But this study focused on intersegmentation of web-derived using UAV images. We also compare the YOLO and MAC-RCNN for automatic web detection. We also have the dataset for future research. The second section is material and methods. For image collection, we did experiment on 10,000 meters in Long City in An Giang province, and the data collected in January 2055, 60 days after the red setting, and to ensure the best presentation and minimize relation, we collected data between 1:30 to 2:30 p.m. drone DJI M2M have been used in our experiment. This drone equipped with RGB camera and multiple spectral cameras. But in this research, around 200 images captured at the height of 2 meters. This used for experiment with 190 images with resolution have been used in this study. In this slide, you can see the location where we collect the data in An Giang province and Long Xi city here. So this is the run we use to collect the data. The overview of study. First is processing graph image to 1024. Finally, we have around 900 images. To fit the model, we separate 50% for training and 20 for validate and testing. In this research, we use two models. First is YOLO with two versions, 8 and 11, in three scales, N, S, and M. For the MaxRCNN, we use three kind different bit backbone. ResNet 50, ResNet 101, and ResNet is. Here is some parameter of the testing. We implement the experiment on the computer with GPU of 12 GB. This is the result of YOLO detection and segmentation. So from this table, we can see the YOLO at S scale can produce the best performance. Otherwise, the MaxRCNN consume a lot of time for training, but precision and response is lower than the YOLO. Reason and discussion. Based on the tables, we can see the YOLO IS can produce the MPA about 0.8 and resistance 0.8 faster than in training. So this effectively for real-time application. Otherwise, MaxRCNN have low accuracy with high segmentation quality but longer training time. Regarding inference time, their both models are compatible. So some challenge in web-derived segmentation we saw is the irregular sharp occlusion and the similarity between right and web-derived. Yes.
Sir, the presentation time is done. Could you please get to the conclusion?
Yes. For the future work, this is the last slide. For the future work, we plan to improve the accuracy by future fusion. For example, from the DJI camera, we can obtain multi-spectral image. So we can combine near image or reject image to fit the learning model for detection and segmentation. So that's on my presentation. Thank you for your listening.
There is one question: why you have used different versions of YOLO models? Can you go to that table where the accuracy and results have been shown?
Thank you for your question. As you know, the YOLO version 11 is the update version, the improved version of YOLO ICE. But when we apply with our data, we saw that although YOLO ICE is the older but other than 11, but maybe it depends on the characteristic of the data set. So for we can see the CNN very powerful the learning method, but it reduce the low accuracy than YOLO. So when we do some experiment, we saw that maybe some parameter of model maybe affect to the accuracies. Yeah, I think so.
Okay, fine. Siddhi, over to you.
Thank you so much, sir, for your presentation. Now, this was the last presentation of today's session. Now we'll proceed to the closing remarks. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We will be happy to see you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. And lastly, I also thank our session chair, Dr. Nitin Sakre, for chairing this session.
Thank you, Siddhi. Thank you so much.
Just a token of appreciation to the chair on the behalf of Team ICTIS 2025 and Global Knowledge Research Foundation and partners. Thank you so much, sir, for your valuable presence. Now, before ending this session, I request all the participants along with the session chair to please turn on your cameras so that I can take a quick snapshot of this conference. We'll just wait for a minute to let everyone turn on their cameras. Nitin, so your face is not visible on the meeting.
Siddhi, I'm not sure. I have turned my video on, but again, not getting what's the issue.
Okay, let me just fix it from my side. Sir, now you'll be able to, I think.
Okay, just a minute. It is giving me an alert. Host has stopped it.
No, I did not stop. Okay. Now I've asked you to start the video. Now you'll be able to. Okay.
Yeah, I turned it on.
Okay, I've taken the snapshot.
No problem.
Thank you, everyone. This was a great session.
Thank you all, and all the best.